Okay, greetings. This is just a walkthrough of this practice test. So problem by problem, completely factor. 36x minus 20. There's a common factor there. I think of 6, right? 36 divided by 6 is 6x. Negative 120 divided by 6 is negative 20. But wait a second. 6 and 20, those are both even. I can actually pull a 2 out of those. If I pull a 2 out of those, that means I've factored 12 out. So 36 divided by 12 is 3x. 120 divided by the 12 is 10. And that's it. Okay, cool. So if you're checking along the way, can you factor the factors? You'll catch it if you didn't pull the biggest one. 6x squared minus 11x minus 30. That's a trinomial. I don't see any common factors. So I'm going to do my two wrongs make a right thing. I'll put the 6x in the first spots there and there. It's a negative 30, so I have a plus and a minus. Factors of 30, 6 times 30 is 180. I need to find factors of 180 that I can turn into 11. I think I see 9 and 20. Yeah, 20 minus 9 is 11. So it's going to be a negative 20, positive 9. Now, those are both wrong. If I take 6 and 9, they're divisible by 3. 6 divided by 3 is 2x. 9 divided by 3 is 3. 6 and 20, those are both divisible by 2. 6 divided by 2 is 3x. Negative 20 divided by 2 is negative 10. And there it is. There's that factor. Cool. This, negative 4x squared plus 36. First of all, I see I can factor a negative 4 out of each of those. If I do that, I get x squared minus 9. Now, I'm not done yet because x squared minus 9, that's a difference of two perfect squares because the square root of x squared is x and the square root of 9 is 3. So I go x and 3 and x and 3, and I go plus minus, and that's it. Okay, next one. X cubed plus 8x squared plus 7x. A common factor of x is there, so I get x squared plus 8x plus 7. That's a trinomial. Yeah, and I can factor it, x and x. Factors of 7 that add up to 8 are 7 and 1. Cool. Cool. Okay, now, this is a long division problem. So I'm going to set up my table, and I'm just going to go there. 10x minus 6 is right there, and I start off with the 40x cubed here. So 40 divided by 10 is 4, and it's going to be x squared because x cubed divided by x is x squared. 4 times negative 6 is negative 24, x squared. Okay, I have negative 24. I need 66. 66. It's going to be a big positive number. 24, 66, 90, I think. Let me think. 90 minus 24 gives me, 66. That's it. 90x squared. 90 divided by 10 is positive 9, and it's going to be x. 9 times negative 6 is negative 54x. I need a negative 104. Negative 50. Yeah, negative 50 plus a negative 54, that's negative 104. Cool. Negative 50 divided by 10 is negative 5x. Negative 5x times negative 6 is positive 30. Well, not 5x. Gonna say I just caught myself. That's not negative 5x. Hold on, I need an eraser for a moment. There we go. It's not negative 5x. There's no x there, right? Because negative 50 divided by 10 is negative 5. The x is already there. Negative 5 times negative 6 is 30. I needed 30. Oh, cool. So that's it. There's my answer right there. Negative 4, not negative 4, positive 4x squared plus 9x minus 5. Okay, the remainder theorem. The remainder theorem, remember, so I find the 0 for that factor. It's negative 7, and I'm going to put negative 7 into there. So I go negative 7 cubed plus 15 times negative 7 squared plus 51 times negative 7 minus 35. I don't know what that is, so I'm going to put that in my calculator. Negative 7 cubed plus 15 times negative 7 squared. I guess I could have put 49, but I just didn't think about that for a second. Plus 51 times a negative 7 minus 35. Minus 35. And I get 0. So this equals 0. So the answer is yes, it's a factor. Make sure you answer the question. If you just put equals 0 and move on, you didn't answer the question. It just says, is it a factor? Yes, it's a factor. And this is my justification. Cool. Moving up here. Answer the following question for the polynomial. How many zeros? 6 degrees, 6 zeros. End behavior. Well, the leading coefficient is positive, so it's going up to the right. And it's an even degree, so it's the same on the left, going up to the left. Cool. Okay, for this polynomial, what's the degree? Well, it's got 3 zeros, one at -2, one at 0, and one at 1. And I saw below that it was asking the 0, so I put it there. Since it has 3 zeros, it's a third degree. The leading coefficient is negative since it's going down to the right. Now, an equation for that, 0, that will have a factor of x. -2 will be x plus 2. 1 will be x minus 1. Cool. And that's the factored form. If I want it standard form, I multiply this through. X times x is x squared. X times 2 is 2x. And that's got to be multiplied by x minus 1. So x squared times x is x cubed. X squared times -1 is -x squared. 2x times x is positive 2x squared. 2x times -1 is -2. And I can combine my like terms there. I get x cubed. These are alike, right? -1 plus 2 is plus 1 x squared minus 2 x. There should be an x there. 2x times -1. There we go. And there's my standard form. Kind of had to squish that in a little bit. Okay. Moving on. There's a bunch of stuff here. Okay, what is the degree? Well, there's 1, 2, let me put the zeros here. This has x plus 1, so 0 is -1. Multiplicity of 1, so it's going to cross because that's an odd number. X minus 4, that would mean it has a 0, 4. And there's multiplicity of 3, so it's going to cross since that's an odd number. X plus 3 gives me a 0 of -3. Multiplicity of 2, and it's going to touch since that's an even number. Cool. So the degree, 2 plus 3 plus 1 is 6. End behavior. It's got a negative leading coefficient, so it's going down to the right. It's even degree, so it's going down to the left. And when I go to graph that, there's a 0 at -1. There's a 0 at 1, 2, 3, 4 right there, and -3. It's going down to the left. It's going down to the right. And here at 4, it's got to cross, so it's going to cross. Where's it going to touch? It touches at -3. Touches right here. So it's going to touch here, cross here, and go there. I guess yeah, there it is. Cool. Moving on. What's the degree here? Oh, I'm going to do the same thing. 2x, that's going to have a 0 at 0, and it's a multiplicity of 1, so it's going to cross. X minus 2, that's going to have a multiplicity or a 0 at 2. Multiplicity of 2 since it's squared, which means it'll touch there. And the next is -4, because -4 plus 4 makes 0. Multiplicity of 2, since it has a power of 2, it's going to touch there. End behavior, 2, 4, 5. It's a fifth degree, positive leading coefficient, so it's going up to the right. Since it's odd, going down to the left. Now, to graph it, I'll graph the 0 at 0, the 0 at 2, and the 0 at -4, and it's going down to the left and up to the right, and it's going to cross at 0, so it's going to cross here, but it's going to touch here, cross here, and touch there. There it is. Cool. Okay. Now, simplify each of these. Okay, to simplify, factor, cancel, list restrictions. Yep, that's right. So 9x plus 90, I can factor a 9 out of there, and I get x plus 10. And then this one, x and x, factors of -15 make 5. Oh, it's going to be a -10 and a +5. So I'm going to stop for a second. X cannot equal +10 or -5. 10, -5. And wait a second. That should be a +10 and a negative 5. Yeah, because 10 minus 5 makes a positive 5. So these are backwards. X cannot be a negative 10 or a positive 5. Cool. That cancels, and I get 9 over x minus 5. Kind of be sloppy there writing. Okay. Next one. And I think this is wrong on the key, so I'm sorry about that. 4x squared minus 25, that's 2x plus 5 and 2x minus 5. That's a difference of squares. All over 12x plus 30. That is a common factor of 6, and I get 2x plus 5 times 3x minus 8, common factor of 3, and I get x minus 6. And x squared minus, oh, that's a trinomial. So factor x and x. It's a negative 18, so plus and minus factors of 18 that make 3 are going to be a negative 6 and a positive 3. Okay, now x cannot be equal to, here, negative 5 over 2. Here, negative 3. Here, positive 6. I'm going to do this before I forget. 3 and 6 will reduce, make a 1 and a 2. Okay, 2x plus 5 cancels. X minus 6 cancels. So I look, I've got 2x minus 5 on the top. And on the bottom, I've got 2 and an x plus 3. Cool. Cool, cool, cool. Okay, now. Next one. This is division. So I've got a factor. I've got to flip this second one, and then I've got to cancel. And I make sure I list restrictions. 3x minus 9. There's a common factor there of 3. And I have x minus 3. X minus 9 doesn't have a factor. Now, I'm going to change it to multiplication, which means I flip, which means this is now on the top. So it's a trinomial, x squared, x and x. Negative 4, so plus and minus. Factors of 4 that make 3 are going to be a positive 4 and a minus 1. And then here on the bottom, it's another trinomial. It comes from right here. X squared goes x and x. Factors of negative 12 that add up to 1 are going to be a positive 4 and a negative 3. So I list restrictions. X cannot be equal to a 9 from here, a negative 4 from here, because negative 4 plus 4, positive 3 because 3 minus 3. But also I've got to think about these, a 1 from there, and a negative 4. But I've already got a negative 4, so don't worry about it. What can I cancel? X plus 4 cancels. Oh, x minus 3 cancels. And 3, oh, no, that 3 doesn't cancel the 9 because that's not a factor. And so I'm left with 3 times x minus 1 all over x minus 9. Cool. And there it is. Now. Where was I? Oh, yeah, here. Oh, these have the same denominator. They're being added. So all I have to go is x minus 4 plus x plus 4, and it's going to be all over 6x squared minus 4x. Well, x plus x is 2x. Negative 4 plus 4 wipes it out, and I get, oh, but look, I can factor this because there's a common factor of 2 there, right? And I get 2x. Yeah, and I get 3x minus 2. And, oh, look at that. 2 will cancel, x will cancel, and I'm left with 1 over 3x minus 2. Okay? Don't forget, even if I canceled everything in that numerator, there's still a 1 there to hold the place, right? Okay. Moving on. These don't have a common denominator, so I've got to factor everything first. This factors into x plus 7, x minus 7, minus 2 all over, this factors into x plus 7, x minus 5. So as I look at that, I need a common denominator. This has an x plus 7. So does this. So that's good. This has an x minus 7. This doesn't. So I need to multiply by x minus 7 on top and on bottom. Cool. This has an x minus 5, and this doesn't. So I multiply by x minus 5, top and bottom. And at this point, these denominators are the same. So I've got 5 times x minus 5, which is 5x. 5 times negative 5 is negative 25. And I've got negative 2 times x, that's negative 2x. And negative 2 times negative 7, that's positive 14. And it's all over that denominator there. Okay. Equals, well, 5 minus 2 is 3x. Negative 25 plus 14 is negative 7. And that doesn't factor at all, which tells me I'm not going to be able to cancel a darn thing. So x plus 7, x minus 7, x minus 5 is there. Cool. And there's my answer. Okay, now let's look at solving. For these, solve the equation. Okay, so I'm looking at x squared minus 8x. That's the same as x times x minus 8. Which means if I do a common denominator between all three of these, I need an x here and here. I need an x minus 8 here and here. Okay, now think about my restrictions. X cannot equal 0 for here or 8. Now that I've got my restrictions and I've got all the denominators the same, I just solve the numerator. X times x is x squared minus 6 times x minus 8 equals 64. That's just the numerator right there, right? Make sure you get that negative. And I didn't distribute the negative up here because I'm afraid if I do, I'll get negative 6x, but I'll forget about that negative there. See, when I do that, I've got x squared, negative 6x, minus 6 times x, negative 6 times negative 8 is positive 48 equals 64. And if I set that equal to 0 by subtracting 64 from here and here, negative 6x, 48 minus, isn't that 16? 48 minus 64, I'm not sure myself right now, minus 16 equals 0. And so if I find the zeros there, I get x, factor that, factor. Okay, minus 8 and x plus 2, because negative 8 times 2 makes negative 16, and negative 8 plus 2 makes that. And so I get x equals 8 and a negative 2. But 8 is one of my restrictions, so that can't be it. So x equals negative 2 is my one and only answer. Cool. Okay. Next one. 17. X squared minus 7x plus 12. That is factored. It makes x minus 4 and x minus 3. So that has an x minus 4. This doesn't, so I need an x minus 4 here and here. And I'm kind of sloppy about that because I don't care about it a lot. And this has an x minus 4, but it doesn't have an x minus 3, so I need an x minus 3 here and here. Okay, my restrictions, x can't be equal to 3 or 4 because they're down here in the denominator. And my numerator is 5 plus 2 times x minus 4 equals 4 times x minus 3. Distribute all that through. 2x minus 8 equals 4x minus 12. Yeah, 2 times 4, 4 times 3. Yep, that works. Excuse me. I'm going to add 12 to both sides. That will get rid of that. And I'm going to subtract 2x from each side. That will get rid of that. So I've got 5 minus 8 plus 12. 5 minus 8 plus 12. Typing it into my calculator gives me 9. Equals 4 minus 2 is 2x. And if I divide by 2, I get x equals 9 halves, which is not one of my restrictions, and that is it. Cool. Okay. Whew. Now, work problems. There's been one on all the tests, right? So the model here, remember, is 1 over the time alone plus 1 over the time alone equals 1 over the time together. So if I go 1 over plus 1 over equals 1 over, I know it's going to look like that. I'm going to set it up. It took Anthony and Travis 6 hours to rake the leaves together. That's a together time. So that goes here. The previous year took Travis 10 hours alone. So that's 10, which means my x has got to go there. And that's going to be the time it takes Anthony to do it by himself. So to do this, all I'm going to do is I'm going to subtract 1/10 from each side. And I go in my calculator, what's 1/6 minus 1/10. I don't want to do that in my head. And I get 1/15. So I have 1 over x equals 1 over 15. If I take a cross product, 1 times x is x equals 1 times 15 is 15. So my answer is 15 hours. Okay. Solve each inequality graphically. Okay, so to do that, I have to set it equal to 0. It's already done for me. Then I factor. Because to solve this, I need the zeros of the numerator and the zeros of the denominator. And I'm going to put them on a number line. So I look here, x equals 4, because 4 minus 4 is a 0. But on the bottom, x cannot equal a -5 or a 5, because -5 plus 5 and 5 plus 5 make 0. So then I make my number line, which always starts at -infinity and ends at infinity. And in between, I've got -5, 4, and 5. And it's a hollow dot at -5 and 5 because it cannot equal them. It's restrictions. And it equals 4, but it's solid because my solution wants to know where it's equal to. Okay, now I just test these. I'm going to test 0. 0 is right in between -5 and 4. 0 is right in between -5 and 4. If I put a 0 in here, I get 0 minus 4, which is a -4, over 0 squared minus 25. I get a negative over negative, which is a positive. Now, guys, I've told you in class a couple of times, if there's no multiplicities of factors here, I know it's going to alternate. So since that's positive, it's going to go negative, positive, negative, positive. You can fill them in just like that. If there's a multiplicity, test each one, okay? Because it could repeat. Now, I want to know where it's less than 0. That's negative. So there and there. And what I've described is -infinity to -5 with parenthesis, and then union bracket on the 4 to 5 with a parenthesis. And that is that. Cool. Next page. Okay, x squared plus 3x is greater than 4. First, I got to set it equal to 0. So x squared plus 3x minus 4 is greater than 0. And I did that by subtracting 4 on each side, like that. Okay, and now I lost my train of thought. Oh, I got to factor because I got to find the zeros, right? So x plus 4, x minus 1, I think, right? 4 times -1 makes -4. 4 minus 1 is 3. Perfect. And so I get from my values x equals -4 and 1 for the zeros for these two factors. And then I put that on a number line, and all my number lines start with -infinity and go to infinity. And I have two zeros. One's at -4 and one's at 1. Okay, and it's hollow dots at both of them. It's hollow because it's not equal to on my problem itself. Then I test. Okay, -4 to 1. Hey, that's if I put a 0 in there, 0 squared is 0. 3 times 0 is 0, and I just get -4. So that's negative if I put a 0 in there. Now, like previous problem, I've said if there's no multiplicity, it's just going to alternate negative, positive, positive, negative, positive, like that. I want to know where it's greater than. Well, it's greater than here and here because greater than means positive. So my interval, my answer is -infinity to -4 with a parenthesis, right? -infinity to -4, union 1 to infinity. Right there. Cool. Okay, asymptote. Horizontal. Oh, all these are about horizontal asymptotes. So horizontal asymptote, you look at the degree. The degree of the top is 2, the degree of the bottom is 1. Top is more, means it's going to be an oblique or a slant. Here, the degree is 1 on the top, 2 on the bottom. Bottom is more. That means it's y equals 0. Here, the degree is 2, the degree is 2. They're the same. That means it's the leading coefficient, which is 4, over the leading coefficient. 4 over 1, y equals 4. There it is. Cool. Okay. Determine the asymptotes and holes for this. So to do that, I've got to factor this. This factors into x, and I think that's a trinomial, right? Because it would be x and x, and because all this would reduce by a power of x. So x squared, x, and 35, plus 7 minus 5. And then this factors into x plus 5 x minus 5. First thing I notice is that cancels. That tells me there's a hole at 5. X equals 5. Cool. And cool thing is, if I put a 5 into the simplified version, so let me show you. 5 times 5 plus 7 all over 5 plus 5, 5 plus 5, oops, 5 plus 5, I get 6. There's actually a hole at 5, 6. Okay, I have never required you to tell me the y value, but there it is. There's a hole at 5, 6. All I've expected is there's a hole at x equals 5. Vertical asymptotes. Vertical asymptotes happen as zeros of the denominator. Well, there's only one thing left in the denominator, x plus 5, and the zero is negative 5. So x equals negative 5. Horizontal asymptotes. Oh, the top is 1 degree more than the bottom. So the top is higher. So it has no horizontal. It will have a slant, though, because the top's exactly 1 more. Okay? That's it. Now, when I'm graphing these, the key is find the asymptotes. Remember, I don't require the range. So vertical asymptote. First, I look at this. See, that canceled. X minus 3. That means there's a hole at the point 3. And if I put the 3 into this equation, into the simplified version, like I did with the 5, I get 2. Oops, make fraction. 2 times 3 plus 1 on the top, 3 plus 1, over 3 plus 3 on the bottom. 3 plus 3 gives me 4/3. So there's actually a hole at 4/3. I like finding the actual coordinate because now I can go 1, 2, 3, and 4/3. That's like right there. There's a hole right there. 1, 2, 3, and 4/3. Okay. Vertical asymptotes are left at the zeros of the denominator. Well, that only has one factor left, x plus 3. So x equals negative 3. Remember to put your vertical asymptotes as lines. They're lines. They're lines. Give me the equations of lines. Horizontal asymptotes, equal degree, 2 and 2. So it's going to be the leading coefficient at the top, which is 2, over the leading coefficient at the bottom, which is 1. And 2 over 1 is just y equals 2. So as I'm graphing these, I already said there's a vertical asymptote at x equals negative 3. So I'm going to sketch that asymptote in there. And there's a horizontal asymptote at y equals 2. So I'm going to sketch that in there. Cool. X-intercepts. Now, x-intercepts, y-intercepts, you can go to decimals for this. Oh, might as well do their domain. All the real numbers except my asymptote of negative 3 and my hole of 3. There. X-intercepts. You can get it from decimals, or you can look at the numerator, x plus 1, and find the zeros. Well, the zeros of x plus 1 are negative 1, 0. So this has an x-intercept at negative 1, 0 right there. Y-intercept, easiest way to find the y-intercept is just put a 0 in for the x. And see, if I put a 0 in for the x, that becomes nothing, that becomes nothing, that becomes nothing. And I get negative over negative, which is a positive, 6 over 9, which is, well, 6/9 or 2/3. So that's like right there. That's like right there on the graph. So my graph looks like this. And if I go to decimals, I see that it's up here. There's my graph. Perfect. Cool. Next page. Okay, last page. Factored form. Nothing will cancel. That tells me there's no holes. Vertical asymptotes. I see 2 factors, so it's going to have 2 asymptotes. One at 4, because 4 minus 4 is 0, and one at negative 3. So x equals 4 and x equals negative 3. And I'm going to go and plot those 1, 2, 3, 4 right here. And 1 negative 3. So 1, 2, 3. There we go. Okay. Horizontal asymptote. I look at the degree, 1 and 2. The bottom's higher. That tells me y equals 0. So it's going to have a horizontal asymptote right on the x-axis. So I make an indication there. Awesome. X-intercepts. What was I thinking? Oh, x-intercepts. X-intercepts. I look at the numerator, and I find the zeros of the numerator, which is just going to be 3/2, because positive 3 divided by 2. So 3/2 is 0. So that's like on the graph, that's 1.5. That's right there. Okay. Y-intercept. Y-intercept, I just put a 0 in for the x value. So if I put a 0 in for the x, check it out. That's nothing, and that's nothing, and that's nothing. And I get negative over negative, which is positive 3 over 12, which is like a fourth, right? So that's like right there-ish. Now, my domain, it's going to be all my real numbers except my vertical asymptotes, 4 and negative 3, and the whole, which there isn't any. Cool. Then I go to decimals, or I can just graph it like here. I follow my asymptotes, and I go to decimals, and it looks like that. So I'm just going to sketch that in there. Remember, the only exact points you need are the x and y intercepts. And they're, whoa, 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 whoa. It's not going to look like that, dummy. That's wrong. Okay, I need to erase that. That's going to really bug me. Okay, sorry. Finish out the asymptote there. It's going to look like this. There we go. Cool. So, wait a second. You dummy, not you, me. That's wrong too. Why'd you guys let me do that? It's actually going to be down here. And I know it's going to be down here because the only time it does this where it kind of goes up to the same asymptote or down to the same asymptote like that is when you have a multiplicity on one of these factors. We talked about that just a little, but I never emphasized it because I allowed you to use decimals. So I know because there's no multiplicity, it's going to alternate down, up on these. Anyway, okay, last problem. Woohoo! Write an equation. It's going to be a fraction, right? Now, asymptotes. There's an asymptote here, a vertical asymptote. Well, that's 1, 2, 3, 4, 5. That's at 1. So if there's a vertical asymptote at 1, it's going to have a factor of x minus, it's a negative 1, x plus 1. There's also a vertical asymptote. It's not at 5 because 5 is right there. It's at 4, right? So x minus 4. Okay, cool. And these intercepts are going to give me factors on in the numerator. Negative 3, that makes x plus 3, and 1, that's x minus 1. Now, look at this for a second. There's a horizontal asymptote. It looks like, yeah, right there at 1. See it? Well, that makes sense because 1 over 1, the degree of the top and the bottom is the same. So there it is. That's it. Okay, guys, that's the whole test. Good luck, and see you next time.